Alright, so good afternoon. Alright, we're going to do question 15. Question 15, tutorial sheet 3, MSM 131. Alright, so so the question says find the roots of the quadratic equations of given subject to the given conditions. So you have x plus k squared is equals to 2 minus 3k. Alright, so you have this quadratic equation. So the first thing that I'm going to do is I'm going to rewrite this quadratic equation. Okay? So I'm going to rewrite this quadratic equation. So it's going to be x plus k, right? Squared minus 2 plus 3k is equals to 0, right? Then I'm going to expand this so it will be x squared plus 2k x plus k squared minus 2 plus 3k is equals to 0, right? Now I need the sum of the roots, which is given as negative b over a. That's the sum of the roots. Then we also need the product of the roots. So we need the sum of the roots and we need the product of the roots. So the sum of the roots, here b is 2k, so it's negative 2k over 1 to just negative 2k. Alright, then we need the product of the roots. The product of the roots is found as c over a. So if you look at c, it's the constant here, anything without an x variable, okay? So the constant in this case is k squared plus 3k minus 2 over 1, which is a, which is just this part, okay? So that is the product. Now the roots that we're dealing with are no longer alpha and beta, but the stated equation says that it has got 2 equal roots. So meaning that the roots in question are alpha and alpha, alright? So meaning that this sum becomes 2 alpha is equals to negative 2k. If I make that the subject, alpha is equals to negative k. This is equation 1. Okay? Next we need equation 2. So to find equation 2, we're going to say the product is now alpha times alpha is equals to k squared plus 3k minus 2. Then we have alpha squared is equals to k squared plus 3k minus 2. Alright? So from this, you actually notice that we have this as equation 2. Alright, now we need to solve this simultaneously. Do we know what alpha is? Alpha is k, negative k. So I'm going to replace with negative k. In this case, now we're going to have negative k squared is equals to k squared plus 3k minus 2. We have k squared, if I take this the other way, minus k squared. Or let's say this is going to be k squared minus k squared plus 3k minus 2 is equals to 0. Alright? These two will cancel, so we have 3k minus 2 is equals to 0 over 3 over 3. K minus 2 is equals to 0, so we have k. Sorry. We have 3k minus 2 is equals to 0, so 3k is equals to 2 over 3 over 3. K is equals to 2 over 3. Alright? So that is the k. K is equals to 2 over 3. Alright. Now, since we are not asked to find what alpha and beta are, this is what our final answer will be. So k is just 2/3. Okay? Question 16. So basically speaking, whenever you are given such a question, the first thing that you need is you need the sum of the roots and the product of the roots, okay? Whenever you have such a question, remember, first thing first, find the sum of the roots and the product of the roots. Then after that, you need to replace according to the stated condition. So in our condition, we are told that the two roots are equal. So meaning if you have the first root as alpha, the next root will also be alpha. If you have the first root as beta, the next root will also be beta. So I simply replaced where there is beta with alpha. Okay, so this is how we got the sum of the roots being 2 alpha, because alpha plus alpha is 2 alpha. Alright? Then we went this side, we said the product of the roots alpha times beta is c over a, so alpha times alpha, this is what we get. The next thing is I needed to solve these two equations simultaneously. That's how we got to this answer, which is 2/3. Right? Question 16. Okay, so question 16. Question 16. Question 16 says if 3x squared plus 13x plus 4 is equals to x plus 4 multiplied by some polynomial, state the degree of the unknown polynomial. State the degree of the unknown polynomial. When we say state the degree of the unknown polynomial, what we're simply looking for is we want to know what is the highest power, okay? So what is the highest power of the variable in the polynomial which is unknown? So now, you've been given a quadratic equation, okay? It says 3x squared plus 13x plus 4, okay? This is equals to 3x squared plus 13x plus 4 is equal to x plus 4 multiplied by some polynomial. Okay? So we're being told that 3x squared plus 13x plus 4 is equal to x plus 4 multiplied by the polynomial. Now the question is that what is the polynomial in question? What's the degree of the polynomial in question? So for us to find the degree of the polynomial in question, what we need to know is what is the degree of this one here? Alright? So if you notice that the degree of this polynomial here is actually what? 2. So meaning when you multiply x plus 4 times some polynomial here, the highest power you should get is what? Is 2. So meaning that the highest degree in this polynomial is actually 1. Okay? So that's the answer. So what is the coefficient of x in the unknown polynomial? So state the degree of the unknown polynomial. We're saying that the degree of the unknown polynomial is just 1. Okay? It's just 1 because when we multiply x times the highest powered variable here, x, which is just x times x should give us 3x squared, alright? Because the degree of this polynomial this side is 2. So what do you need to multiply to give you 2? It's just 1, okay? So that is what we get. Remember, multiplication is different from addition. If you multiply 2 of the same bases, what do you expect? The powers are going to be what? Added. So 2 variables of the same base when multiplied is addition of powers. So meaning this x multiplied by some other x the power will actually increase from 1 to 2. So meaning this one should have a degree of 1. Okay, that is that. What is the coefficient of x in the unknown polynomial? So now, we're looking for the coefficient of x in the unknown polynomial. How do we find it? Alright. So the first thing that we need to look at is when we multiply x plus 4 times some polynomial, meaning this thing should give us what? 1. So in short, I can write this polynomial as a straight line. So that's a straight line. So we have x plus 4 multiplied by ax, or we can say mx plus c. Maybe because you remember this, y is equals to mx plus c. Alright, yeah, so that's the equation of a straight line. Alright, so now what we have is, if you multiply this times this, the coefficient of x, now they didn't say x squared, right? So they didn't say x squared, so we need to first multiply this so that we know exactly what the coefficient is, right? So if we expand this, what do we get? Expanding this, what you will notice is that x times mx is mx squared plus x times this is cx, right? Plus 4 multiplied by that, that's 4mx. 4 times c, that's 4c. Okay, so I've simply expanded. So there's just an expansion which has taken place there. That's all I've done. Alright. From there, what we now get is, remember, I can actually factor out here. So we have mx squared plus, remember, c. We are going to have c plus what? 4m. Alright. X plus c x times, this one is a constant, so you maintain it as 4c. Alright. So now I'm going to compare with this. Alright, so basically speaking, this is equal to that. Alright, so now you're being asked what is the coefficient of x in that quadratic expansion. So the coefficient of x is simply m. Okay, so we're looking for m. So how do we find m? There are two ways we can find m. We can actually see that m is actually 3. Alright? Because the coefficient of m, x squared here is m, then x squared there is actually 3. Then we know that c is a constant, so we can say 4 and c here. So you will notice that 4 is actually equals to 4c over 4, so we have c is equals to 1. Alright? Then even if I was solving for m, I can say 13 is equals to c plus 4m. Right? But we know c is 1. So we have 13 is equals to 1 plus 4m. Then we have 13 minus 1 is equals to 4m over 4. Over 4, 13 minus 1 is 12. 12 over 4 is equals to 4m. It's equals to m. So m is actually 3. So I did not even have to be the one to solve that. Because as I said, if you look at the coefficient of x squared where m is, you notice that the m is given as 3. So we're saying that for this polynomial here, what we have is, if you multiply this polynomial times, this x plus 4 times some polynomial, you expect to have what is on the left hand side, okay? So now, what we know is, what is the degree of this polynomial? It's 1, so it means it's a straight line, mx plus c. So we've been asked to find the value or the coefficient of x, so meaning we're looking for m, okay, in this polynomial. It says, what is the coefficient of x in the unknown polynomial? So if I expand this, you notice that we have mx squared plus cx plus 4mx plus 4c, right? So this is what you have. If you compare the right hand side and the left hand side, you notice that the value of m is actually 3, right? So the value of m is 3. So I didn't need to solve all this. All I needed to state was that m is equal to 3. So the coefficient of x is actually what? 3. So, or alternatively, well, the first thing you need to know is, we know the coefficient of x in this is c plus 4m, but we don't know what c is. But we know that c is the constant, the part without c. Yeah, c is a constant. But now, if you look at this and this, you notice that here the constant is 4, the part without an x, okay? So we have 4 here, but on the other side, which is the right-hand side, is 4c, right? So if you compare the two, you actually find that 4 is equal to 4c. That's how we found. Then I divided both sides by 4, then we ended up having c as 1, okay? Now that we know that c is 1, I'm going to replace 1 where there is c in this one here, c plus 4m, and I'm going to equate this to the coefficient of x. So coefficient of x this side is 13. So we have 13 is equals to the coefficient of x on the right hand side is c plus 4m, okay? But do we know what c is? So we're saying the coefficient of x on the left hand side is 13, and the coefficient of of x on the right hand side is c plus 4m. But we know that c is 1, so I replaced c with 1, and what we get is solving for m, and it goes back to 3, right? So that's the answer. So the answer is basically 3. Next up, determine this polynomial. Right. So we want to know what that polynomial is, and I found that c is 1 and m is 3. Okay, so we know that c is 1 and m is 3, so c is 1 and m is 3. So what is the polynomial? The polynomial is mx plus c. Alright, so m is 3, so it's 3x plus c is 1, so this is the polynomial. The polynomial we're looking for is 3x plus 1. That is your answer. Alright, so the polynomial in question is simply 3x plus 1. Question 17. Question 17. Okay, so question 17 says simplify these algebraic fractions, leaving the answers in their lowest terms. Okay, we're trying to simplify, leaving the answers in their lowest terms. Okay, so how do we get there? Okay, so simplifying shouldn't be a problem for anyone. Simplifying shouldn't be a problem for anyone. So, 17, part A. We have 3x to the power 4. Okay, so we have 3x to the power 4. So we have 3x to the power 4 minus 21x over 3x. We have 3x to the power 4 over 21 minus 21x okay. So simplifying this, all we are going to do is I'm going to factor out what is common. So 3x is common, what remains we have x to the power 3 minus 9, okay? Because we know actually 7. Okay, because we know that 7 times 3 is 21. Okay, so over 3x, then these will cancel, so the answer is x cubed minus 7. Okay, so that's your answer, x to the power 3 minus 7. That is our final answer. Next question. Two x squared minus 8 over 2 minus x. Alright, so we have a question of that nature. Now, what we're looking for here is what do you notice about this? Is this difference of two squares? Okay, so let me write it for you here. If I wrote this as 2x plus 4, okay, then we have 2x minus 4. Okay, so for starters, one thing you need to know is that this particular value here is not equivalent to that. Okay, so what we'll basically do is, instead of expanding, right, we know we cannot factor out the 2x squared minus 8. We can actually rewrite this, and we can also rewrite that. Right. Now, I'm not so certain if maybe some of you have seen this before. We have difference of two squares, we also have sum of squares. Okay, so if you notice, this actually looks like 2 to the power 3. Okay, because 2 times 2 is 2, 4 times 2 is 3. So that looks like the cubic root. Okay, but let's factor out 2 here. If I factor out a 2, what remains? You'll notice that what remains here is x squared minus 4, right? Over 2 minus x. Alright, so after that now, this looks like what? Difference of two squares. Okay, so we are going to have 2x minus 2 x plus 2, everything over 2 minus x. Alright, so now to make the denominator look like this one, I can factor out a negative. Alright, so making the denominator look like that, I have to factor out a negative. So what we're going to have is, now we're going to have 2x minus 2 x plus 2. Alright, then from here we're going to have everything over negative, I factored out, so now it has x minus 2. If I multiply this, this will be negative x. If I multiply this, this will be positive 2, so I have not changed anything. Okay, so this and this will cancel, so now we have negative 2x plus 2 as our final answer. Okay, so what we're saying is, for you to find this, you needed to first factor out a 2. So this is the 2 that I factored out. Then from here, we have x squared minus 4. Okay, 2 times x squared is 2x squared, 2 times negative 4 is 8. Alright, over 2 minus x. Then from there now, what we're going to find is, you notice that this is actually difference of two squares. Okay, so by writing it as difference of two squares, this is x minus 2, x plus 2. Okay, over 2 minus x. Now I'm going to factor out a negative. This and this do not look the same. Okay, so how do I make them look exactly the same? I'm simply going to factor out a negative from one of them. Okay, so doing that, I factored out a negative from the denominator, so that the 2 develops a minus and the x becomes positive. So this is what we did here. So I factored out the negative, then it became x minus 2, so it looks like the numerator. So I can cancel out the denominator and the numerator because this one and this one are common. Now, ladies and gentlemen, the common mistakes that I've seen students make is whenever they see something common in the denominator and numerator, they still cancel it regardless of it being plus or minus, okay? So the only time you are allowed to cancel out what is common in the denominator and in the numerator if the numerator variables are actually multiplying, okay? So if multiplication is in the numerator, so if it was posed plus here, in between here, if there was plus or minus, you cannot cancel out even if this looks like that, okay? So that's the only time you cancel out. End of that question. Okay, next up, we have 2x to the power 3. Okay, 2x squared plus 7x minus 4, everything over 2x squared plus 9x plus 4. Okay, so now, how do I simplify this? I'm going to look for the product and the sum, alright? So what is the product and what is the sum of the denominator? So if we look at what we have, you notice that the numerator here, the product is negative 8 and the sum is 7. Okay, so for the numerator, product is negative 8 and sum is actually positive 7. So what are the two factors? The two factors, so I'm simply factorizing the numerator and also factorizing the denominator. Okay, so that's basically what I'm doing. So for the numerator, what is the product and the sum? Negative 8, sum is 7, and factors. What are the factors? So we're looking for two numbers that when we multiply will give us negative 8, and when we add they'll give us 7. So if you really closely look, you notice that negative 1 and 8 are the factors. So we're saying negative 1 and positive 8, alright? So we can write, then for the denominator now, what are the product and the sums? So the product for the denominator is 8 and the sum is 9, okay? So the factors again are 1 and 8, right? Because if you multiply 1 times 8, that's 8. If you add 1 plus 8, that's 9. So writing, factorizing the numerator, we're going to have 2x squared plus, now I'm going to replace the products and the sum, so plus x, actually minus, because it's the negative 1, minus x plus 8x minus 4 over the denominator, if I write it in plus x plus 8x plus 4, okay? What's common here? We have x is common, 2x minus 1, plus 4 is common, then we have 2x minus 1. Everything over the denominator, we have x common, then we have 2x plus 1, okay? Because from here that's 2x plus 1, then plus 4 is common, from there then we have 2x plus 1, alright? So from the numerator, from here the numerator ends up becoming x plus 4 multiplied by 2x minus 1, and the denominator ends up becoming x plus 4 multiplied by 2x plus 1, alright? So now this and this will cancel, so the final answer is 2x minus 1 over 2x plus 1. So that's the final answer, 2x minus 1 over 2x plus 1. So basically speaking, I simply use the factorization method in the numerator and also factorization method on the denominator, okay? Then after using those two, I simply found the products for the numerator and the sums, and also product and sum for the denominator. This is what I replaced. Then the next thing is I simplified, all right? Then we ended up having x plus x, 2x minus 1 plus 4, 2x minus 1, then x over 2x plus 1, plus 4, 2x plus 1, right? Then we ended up having x plus 4 multiplied by 2x minus 1 over x plus 4 multiplied by 2x plus 1. So these two are common, I can cancel them out. What remains is 2x minus 1 over 2x plus 1. So those are the final answers that we get. All right. D. Okay, so to simplify D, we have two methods that we can use. This says 2x cubed plus 3x plus 5 divided by x plus 1. Alright, so for me to simplify this, I'm going to use